this video, we're going to continue topic 6.1 and 6.2, and we are going to look at example 11. So on the AP test, they very rarely actually present this with a function. It's usually presented in a table. So I 100% guarantee you're going to see the table on our unit test. And you think about it with the table, is this a way to get average rate of change? So this is a really good free response question, because part A can be average rate of change and part B can be you find a right Riemann sum or a trapezoidal sum. So in this one, they give us a scenario that we've got a rectangular canal 5 meters wide, 100 meters long, as an uneven bottom. Depth measurements are taken every 20 meters along the length of the canal. Use the depth measurements to construct a Riemann sum using right endpoints to estimate the volume of the water in the canal. They didn't give us where to go to and from, so typically we use the whole table unless they state otherwise. It did say we wanted an RRAM, and if I count the number of places, I see 1, 2, 3, 4, 5 rectangles. So I'm going to set up for 5. And notice my heights are already calculated, and I have to calculate, and my distances in between I have to calculate. So I'm going to start from the right. So I'm only going to use the height 1.9 and the distance in between of 20. And then I'm going to use the next height of 2.1 and the distance in between of 20. I'm going to use the next height of 2.1 again, and the distance in between is 20. And then I'm going to use the distance in between, or sorry, the height of 1.8 and the distance in between of 20 again. And then the height of 1.6 and the distance in between of 20 again. And you'll notice I never use the 2.0 height because we were coming at it from the right. Again, I am probably going to use my calculator, and I'm going to crunch my numbers in my calculator just to help me out with the arithmetic piece. And when I do this, I end up with 190. And technically this was an area problem, so meters squared. However, in this particular case, which probably won't happen in our homework here, but could happen on the AP test, they actually want us to calculate the volume. That's technically the area. To get the volume, we would want to multiply it by this 5 that we had here. So to do the volume, to finish this one, we would do 190 times 5, which is really the area of the base times the height of the canal, which would give us 950 meters cubed. Let's see if we can do a couple more in this video. So this one is just a random data table. So we're supposed to use it to find a right Riemann sum. And then we're supposed to decide if it's an overestimate or an underestimate. So we don't want to forget that part. So again, I'm doing an RRAM. I want to count how many rectangles I have here. So because they didn't really tell me, so I'm going to use the whole table. So 1, 2, 3, 4, 5, 6. So I'm going to set up for 6. Okay. And then again, I'm going to use this height because I'm coming at it from the right, 21, and then this distance in between, which is 10. Then I'm going to use this height, 18, and this distance in between. Oh, interesting. See, this time it's not consistent, so it's 15. This height, 12, and then this distance in between, which is only 5. And then this height, 9, and then the distance in between, which is 5 again. This height 7, and the distance in between looks like it's 10. And then this height 5, and the distance in between is 15. By setting up that skeleton, I know when I've run out of space, I stop writing things. All right, and then when I crunch all those numbers, again, using my calculator, I get 730. Now, I need to understand if this is an overestimate or an underestimate, so I always just sketch my picture. A quick sketch. So I am noticing that this function, it keeps the y values keep increasing. So I know I've got a strictly increasing function. And then I just start drawing my right Riemann sum. I know if to draw a right, I go from the right and draw a rectangle, go from the right till I hit the function. And you can very clearly see that I'm definitely over the actual function. So I know that this has to be an over estimate. We're going to do one more quick one in this video. So we're going to do example 13. This time it says that we are going to do a left Riemann sum. So I got to set up for an LRAM. And let's see, 1, 2, 3, 4, 5, 6 rectangles again. Okay, and this time I'm going to start from this height because I've got to start from the left. So I've got a height of 4 and a distance of 15, a height of 5 and a distance of 10, a height of 7 and a distance of 5, a height of 9, and a distance of 5, a height of 12, and a distance of 15, a height of 18, and a distance of 10. All I'm doing to get that distance is I'm subtracting the two numbers, and I really want the absolute value of it. It shouldn't be negative because it's a geometry thing. We don't do negative in geometry. When I multiply this out and add it up with my calculator, I get 550, and we wouldn't put a unit measurement on these typically. I do need to, however, figure if it's an over or under estimate, so I'm going to look at this. It looks like my values, as I'm going up, my y values are increasing, so I'm a strictly increasing function. And then I'm going to draw my little sketch as I'm coming at it from the left. So I'm going to hit the function from the left, hit the function from the left, hit the function from the left, and you'll notice I've got the gaps underneath there, so this has to be an under estimate. And remember, we can only do over and under estimates if I have a right or left Riemann sum.